Hello, everyone.
Hello.
Hi, just to check, should we start or should we wait for a few more minutes?
I think we can wait until, now that I'm sharing my screen, I can't see the time, maybe 2 minutes, and then we'll start at past.
Great, thanks. Hi, Zach. So can I start?
Yep, go ahead.
Hello, everyone. Welcome to the breakout session for infrastructure for research software. I'm Cerlane from ETH Zurich, Swiss Supercomputing Center. Sorry, my brain is not working so well today. First of all, I would like to encourage you to use the hashtag EOSCsymposium 2021 for social media interactions. So thank you very much. So today we'll be welcoming 5 speakers for this session, and each will have 10 minutes for their presentation. I hope that we would have some time towards the end for some Q&A. So hopefully this will work out. If not, we can squeeze in a simple question if you use less time than required. So to leave more time for Q&A, I'm going to jump right in. So I would like to welcome the first speaker, and that would be Pablo Orviz from the Spanish National Research Council and EOSC-Synergy, who will be presenting to us SQAaaS as a service, the toolkit to streamline quality-oriented practices in research software. So the floor is yours, Pablo.
Thank you a lot. Thanks for the opportunity to present and share our work. As you said, today we are going to present the software quality assurance as a service, which is also known as SQAaaS with this acronym. Next slide, please. So this framework, this platform is being developed within the framework of EOSC-Synergy project, which is integrating national infrastructures and thematic services within the EOSC context. And for that, we are using a software quality assurance approach, expecting that this will increase the usability and also foster the adoption of these thematic services. So the platform provides two modules for a twofold objective. The first one is bring over the novel software engineering practices close to researchers. And for that, we will use a DevOps methodology. This is actually a common struggle for researchers because there are many tools out there, each one with its own language. On the other hand, there is no clear software quality criteria that they should fulfill in order to create quality-based research software. And our implementation harnesses this concept of the pipelines, which is a DevOps concept. And that's why this module is coined as pipeline as a service, since it provides a way to create customized pipelines. And a second module is the quality assessment and awarding. This is targeted not only to the developers of research software, but also to other actors or stakeholders in the research ecosystem. It provides a SQAaaS assessment tool and has the extended capability of issuing digital badges that, as we will see, they are verifiable and shareable. Next slide. So the SQAaaS is being used by the thematic services inside the EOSC-Synergy project. They are using the platform in order to compose ad hoc pipelines, depending on the requirements. But this is a mutual beneficial, let's say, relationship because they are also validating our work and the operational part of the SQAaaS platform. So these thematic services cover different scientific fields such as Earth observation. Next slide, please. Biomedicine, astrophysics, and environment. If you want to learn more about these thematic services and their approach, and this quality approach that they are following in order to integrate it in the EOSC, please mark your calendar because tomorrow there is a talk about it presented by Ignacio Brenker. Next slide. So delving into the building blocks that compose this platform, we first need to decide what CI/CD, continuous integration, continuous delivery technology we are using in order to implement the DevOps approach. And for that, the Jenkins pipeline as code was the perfect fit for us because it's open source, can be deployed on premises, and also has a strong community behind. So once we have this technology, we need a criteria. I mean, we need the quality criteria that we need to check, that what criteria we need to prioritize. And for that, we come up with two sets, one for software and one for service, collecting these criteria. Once we have the criteria, we need to implement this criteria, and not only that, but also provide the operational environment in order to perform this test. And for that, we have developed the Jenkins pipeline library, also known as JPL. And then it comes the portal. The portal is the graphical website that provides this easy way to benefit from the potential of the library, which is the JPL library. And not only that, since as we have already commented in the first slide, we also provide an SQA assessment and the capability of issuing badges that we use this open badges specification in order to do that. Next slide. So a few notes on the quality criteria. As I said, we have two different documents that you can see on the right. There you can see also you have the DOIs of the latest version, and also the link to the GitHub repositories that they are public access. And this is because we want that anyone that is willing to participate and provide feedback about these criteria is very welcome. The criteria each criterion has its own code, so we can identify it correctly whenever we use them in the JPL library and also through the SQAAS portal. And obviously it's research oriented and has this DevOps nature, because we would like to work towards the reproducible and sustainable research software. Next slide, please. So a few notes on the library. This is the core component because it implements the quality criteria. And as you can see in the start on the right, it uses a YAML configuration file, so it's kind of easy to use. So this library can be directly used. You don't need to go through the SQAAS portal, but this requires that the developer has some knowledge in the Jenkins pipeline as code and also in Docker Compose for composing the service orchestration. Next slide. And then we come to the portal. The portal is the one that offers these two modules that we have talked about in the first slide. The first one, the pipeline as a service, is now available. We have implemented it a few weeks ago, and you can access to this module in the URL on the right. And then we have this quality assessment and warning that is currently work in progress. Although we have tested successfully a proof of concept where we could issue digital badges, and we think that once this is ready, it could be a next step in the consolidation of EOS services, and we'll be able to provide information about quality and related information. Next slide. So you can see here two screenshots of the SQAAS platform, in particular the pipeline as a service module. As you can see in the figure on the left, and also in the menu on the left, you see that it's a stepwise process where you first define the repositories, then the services that will be fired up for the environment, for the testing environment, and then the criteria, where you select the criteria that you want to fulfill. If everything goes correctly, you will see something similar to the picture on the right, where you can download the pipeline, and it's ready to be used in your code repositories. Also, you have this handy feature where you can try this pipeline and run this pipeline in our premises, so you can check if it's doing the expected work. Next slide. So a few notes on the certification part on the digital badges. As I said, we are using open badges, and through the implementation, the Badger Europe Cloud Service implementation. So we have created there a EOSC-Synergy project issuer profile. So we are now able to issue these 3 different levels of badges. One of the most important things of choosing open badges specification is that we can bake metadata inside the badge. So 2 things that are important that we are baking right now inside the badge is the earning criteria. So this is the very specific codes that we use in the software and service criteria, the ones that have been fulfilled. And also, as evidence, we provide a permanent link to the continuous integration system build. So this includes, in this link, you can also, it's align the code version, the artifacts that were produced, and also some other information in the building reports. Next slide. So this is the proof of concept. So whenever the pipeline has been successfully executed, we issue the badge. Next slide, please. So the multiple interfaces of the SQAAS, well, the most obvious one is through the web portal. So here you don't need any previous expertise on continuous integration, because this is graphical and it will hide this complexity for you. And then you can use, as I said, the Jenkins pipeline library, which is the one that the API server uses directly. So this is probably more suited to more skilled developers. And regarding the module of the awarding, whenever this is, I mean, this is can only be done through the web portal in the API server, and these badges that we are issuing can be then shared in whatever platform. But for example, one of the meaningful ones should be the EOS portal. Next slide. So just to end, this is my final slide, the remarks. We are waiting for your collaboration with regards to the SQAA criteria baselines. This is an open and collaborative effort, and probably this is the way to improve our current criteria. As I said, the SQAAS portal hides the complexity of the underlying technology, so the developer is not required to learn the specifics of the CI system, CI tool, and the language. Also, the digital badges, the metadata uniquely identifies the SQA assessment, and also, well, as I said, the thematic services are very valuable, provide very valuable feedback for us in order to develop this tool, and hopefully this is also important for them in order to enhance their usability and the subsequent adoption. So be sure to try the SQAAS platform at SQAAS.EOSC-Synergy.eu, and if you want to try the pipeline, the library, the JPL library, you have also there the link. So thanks for your attention, and this is all from my part.
Thank you, Pablo. That is a very interesting presentation. I see that our task force and what you have done has many alignments. So we look forward to working with you.
Okay.
So I will move on to the next speaker, who will be, I'm hearing echo, so perhaps, yeah, thanks. So the next speaker will be Daniel Garijo. I hope I pronounced your name correctly. And I have to say I can't do that part, so I will say University of Madrid. And he will be presenting towards reusable research software. So the floor is yours, Daniel.
Thank you very much. Can we go to the next slide, please? Thank you. So I don't think I need to convince anyone today on how important software is for academic publications, right? So, but I would like to highlight the role of software because I think it's critical for not only like as a research contribution by itself, but also for the importance that it has for research data, because a lot of research software is used to actually curate, process, analyze, or even produce, in some cases, research data, and how it is actually composed, right? It's the atomic piece that we use in computational methods for producing the workflows, such as the ones that the previous speaker was speaking of, right? The pipelines. And we have seen that the community has pushed forward a lot of infrastructure that is already there. Some of it that it's already being reused by EOSC, and on top of which we are building to help store all these research artifacts, research data, software, and methods. Next slide, please. However, today I would like to reflect a little bit on the challenges that the users face when reusing, and also when they design software, right? We have these two types of users. From the software user point of view, the challenges that they face, or at least from all my communications with them, is that what they want is to understand very quickly what the software component does, especially when they need to assess it for reuse, how to transform their data to the format that that software component is going to be accepting, how to transform or interpret the results produced by that piece of software, and then, of course, how to easily invoke and configure that piece of software so they can quickly obtain the results that they are looking for, and then compare it with other similar methods. In fact, what I've seen is that in some environmental sciences, for example, when the complexity of this is very high, for example, hydrology models, people that are not experts in hydrology model, but use a hydrology model for example, coupling it to another model, then they will find a hydrology model that they know how to use, and they will stick to it, because the complexity of switching to another one is so high, right? And to appropriately configure it. Then from the software designer point of view, the challenges are different. These are experts sometimes that they know a lot about their software, but they don't know that well how to actually make explicit the dependencies and installation procedures that are needed to actually make other people reuse their particular software. And yes, all of the people in this seminar may be very familiar with Docker and other infrastructure technologies that can be used for this purpose, but scientists are often not that familiar with them. Then there are other challenges, like how to properly encapsulate in software, defining the inputs and outputs. You cannot imagine the amount of times that we see paths that are hard-coded into the files that we are compiling, and so on and so forth. And then how to describe it so others can use it, because sometimes there is a lot of implicit knowledge that is not explicitly stated in the metadata that goes with the component. Next slide, please. Fortunately, I've seen that the community has pushed forward many standards to help address these problems. And starting from the description point of view, schema.org and code meta, in particular code meta, is a lightweight vocabulary that actually helps describing software at a high level point of view, and that can be combined, for example, with a common workflow language, which is a very detailed vocabulary, well, a specification to actually describe what are the input and output types that go with a particular software in order to encapsulate it as a configuration. From the packaging point of view, and here packaging, I am talking about the context rather than producing an executable package. By context, I mean, for example, example files, a sample configuration, sample results that are usually surrounding this research software and usually travel together in order to facilitate reuse. So there is the research object standard specification, well, specification that is being increasingly used by the community and software and projects by Reliance in EOSC. Then we have aggregators like OpenAir, which are fantastic because aggregate a lot of metadata and try to identify whether two different pieces of software are the same or not. And then we have domain-specific and general registries, where metadata registries where one can deposit their stuff, such as Zenodo. And a community around these registries is also emerging to define best practices that the owners of these resources should follow in order to make sure that people know where they are getting in. Next slide, please. However, well, still software metadata is not that machine readable, and it's not a problem of abundance, right? I've had a lot of conversations with scientists that whenever I, as an owner of a registry, I went to them and say, oh, could you please describe your component in this form or this structure format that we are handling so we can help finding it later? And they say back to me, well, you know, I already did this. Have you seen the README file? Have you seen the 15-page manual documentation that I put in the GitHub repository? Have you seen the website? Have you seen the papers? So all this information is already there, right? And the problem is that this is not machine readable. So in the end, a lot of effort has to be put on by domains, by domain experts to read through these documents and actually annotate this metadata by hand. This is what happens in many domain-specific registries. Next slide, please. So in order to address some of these problems, what I've been working on with my group in the last couple of years is in developing software metadata extraction frameworks that will go, for example, will take as input a GitHub repository or a README file and will attempt to extract up, I think it's more than 20 common metadata fields. I think it's around 28 or so that include installation instructions, description, invocation command, license, authors for credit, and so on and so forth. And it will expose all this information in a structured manner, for example, by generating a code meta file. And you can find more information in the paper and in the links in the slides. Next slide, please. Another thing that we have also been gearing towards is how to actually make this metadata machine actionable to create knowledge graphs. Knowledge graphs where the nodes of the graph are the entities of associated with software, such as a software entry, an author, a license, etc. And the edges between these graphs are the properties, the relationships between them. And by enabling this through from the previous descriptions, what we get are that we can enable executable software components that are way more portable than we used to have. It has saved us a lot of time when specify different configurations of software that we need to redeploy in other settings. And also we have used this to actually describe the input and output types to the level of the variables that go within that input and output types. For example, in a hydrology model, it's very, very important to know that a certain file will contain the precipitation rate and the units in which this precipitation rate is, right? And we need this because, well, otherwise we cannot automatically do the data transformations that are needed to put the data in the format that is required. The same for the output formats, and so on and so forth. And what is important is that now, once we have these knowledge graphs, we can start doing some interesting reasoning techniques to actually help validating parameters and suggesting parameters when one does not know what is the right value that should go on for that particular configuration. Next slide, please. And since I'm running out of time, I would like you to walk out with the message that software metadata is great, but I think we should start thinking how to make it machine actionable and how to make it useful for what the users want, right? Which of course include findability, but more importantly, what they want is to understand the differences between two different components. They want to help the portability of their software. They want to help link their software to similar software methods. They want to build automated comparison benchmarks, and in general, improve their credit that they obtain for what they are writing and reduce the time needed for adapting existing tools to their current pipelines. And with that, next slide, please. I would like to end my talk, and I'll be happy to accept questions if you put them on the chat or afterwards. Thank you very much.
Thanks, Daniel. That is, again, a very interesting talk. So once again, I really like what you have been sharing, the practical challenges in enabling reusable software, which is not so easy, in particular because we're not targeting computer scientists, but real domain specialists. So we will look forward to that for your inputs in the task force if you are willing to join us. Then I will welcome the next speaker. That would be Sonja Filiposka from FCSE, UKIM and Ni4OS-Europe, who will be giving us a talk on Ni4OS-Europe pre-production environment. So the floor is yours, Sonja.
Unfortunately, Sonja could not be here with us at the moment due to medical emergency, so I will try to present the Ni4OS-Europe pre-production environment on behalf of her, if you agree.
Yeah, thank you, Dusan, for stepping in.
Yeah, so my name is Dusan Vudragovic. I'm from the Institute of Physics Belgrade, and together with Sonja, I'm working on the Ni4OS-Europe pre-production environment development. So we can start with the presentation. Next slide, please. So within the Ni4OS-Europe, we think that the technical performance of resources that are exposed through the EOS catalog could be accurately measured only by deep integration between the EOS exchange and the EOS core layers components. And from such integration, we expect that such integration will create a unique metric for measuring resource performance in terms of utilization, provided support, availability, and the reliability. And in order to somehow solve this problem within the Ni4OS-Europe, we deployed a development environment, and the name of this environment is pre-production environment. And our aim is with this environment is to somehow accelerate integration between EOS exchange and EOS core layer. And here today I will present the main components of our pre-production environment. So next slide. On the next slide, you can see these main components. So Ni4OS-Europe pre-production environment includes catalog. So this is service portfolio catalog management system, and the role of the catalog is to give consistent overview of the onboarded resources, which includes information about what resources are offered, their operational capacity, how they are accessed, etc. So a full set of the policies that includes user guidelines, privacy policy, access policy, terms of use, etc. Also, another component is authentication and authorization infrastructure, which is responsible for seamless access to all resources. Then we have also monitoring system, which measures the performance of the research in terms of availability and reliability, and also it ensures permanent status checking and alarms in case of service outage. Also, we deployed accounting system, which measures the performance of research in terms of utilization. And also we have support system, which consists of tools for providing support to end users and research providers. But also our support system also includes a training portal and then technical wiki with more technical documentation on how to integrate on how to establish integration between research and pre-production environment. So now I will quickly go through the components, but in the presentation you will find the link to each component, so you will be able to find further details in that way. So let's start. On next slide, we will see the central tool of our pre-production environment. This is catalog portfolio system, and it is based on Agora technology. So practically all information about resources and providers are collected here. So what is important regarding the Agora strictly follows the EOSC profiles specification, so it is fully compatible with the EOSC marketplace, and therefore for some time our Agora team in collaboration with the EOSC team works on integration of the Agora catalog with the central EOSC marketplace, EOSC catalog, and we expect that very soon this integration will establish a trusted channel between these two catalogs, and once the resource or provider is marked as onboarded within the NI4OS-Europe catalog, it will be automatically published into the central EOSC one. On next slide, you can see help desk. So our help desk system is based on OTRS technology, and for all resources that have been previously registered within the catalog, we have created a dedicated queue within the help desk to try somehow to assess the quality of the provided support. On next slide, you will see that we have also the deployed authentication and authorization infrastructure as NI4OS login service. So NI4OS login enables the integration of external identity providers from EduGain or from individual organization with the services and resources offered via NI4OS Europe. Also, social identities are supported by this service. Then on the next slide, you will see that we have a deployed monitoring system. It is responsible for continuous status checking of all onboarded resources via our project, and also it is able to generate availability and reliability reports, and to send alarms in case of any problem with services. Monitoring system is based on Argo technology. Also, as a part of pre-production environment, on the next slide, you will see that we have deployed training portal. So it is based on Moodle and Biglu button. So these technologies are used for establishing of the training portal, and all training material that are produced by our project is uploaded to this place, so you can visit and access. Also, as a part of pre-production environment, on the next slide, we have deployed technical wiki, and this wiki contains all technical guidelines of how to integrate particular research with our pre-production environment, and other useful technical documentation related to the EOSC. So these are the main components, and as I said, our pre-production environment allows research developers to test integration of their resources with the EOS core components, because all components from our pre-production environment are fully compatible with the EOS core ones. And we believe that supporting integration between EOS Exchange and EOS core layers, we will enable assessing the quality of resources provided via portal, because otherwise, without such metric, I think that the quality of the onboarded resources cannot be compared from the end user perspective, because there are no criteria that could facilitate choosing the most suitable resource for a particular user's case. In other words, all resources within the quality are equal from the end user perspective without such metric. So thank you for your attention. If you have any question, you can use the chat.
Thank you, Dusan. And once again, for stepping in for Sonja on short notice. I really appreciate it. And thank you for the very interesting presentation on the pre-production environment. I somehow feel there's already close to production as opposed to pre-production kind of environment. Thank you. So let us move on to the next speaker. That would be Nici Pfeiffer, I hope I did not pronounce your name wrongly, and Eric Olson from the Center for Open Science, who will be sharing with us OSF and improving the researcher experience. The floor is yours, Nici.
Thank you. And this is Eric Olson from the product team at the Center for Open Science. Nici is also here hanging out and watching for questions and thoughts. So yeah, we're going to talk a little bit today about the OSF. So you can take the next slide, please. Thank you. So the Center for Open Science is a nonprofit. We're based in the US, and our mission at the highest level is increase openness, integrity, and reproducibility of research. You can go to the next slide. And so this is an image you're pretty familiar with, I'm sure, the diffusion of innovation. And we use this as a way to frame the work that we do at the center, which is, we're going to talk mostly about the OSF today, but we do a lot of work that overlaps with that technology development. And you just click again here, I'll show you kind of how we structure our work here at the center. So in order to make things, to enable the early adopters to get excited and try new things, and particularly practices that would move us toward the manifestation of our mission. We develop infrastructure like the OSF that we're going to talk about today to make it possible for these users and these communities to try and implement these practices in their work, and then continue to iterate and make those practices even easier for them to make that part of their research life cycle. And then as we continue to communicate with research communities about this work, and demonstrate that there is real value with the work that with these practices. We have a research team in addition to the infrastructure team here at the center that is actually researching research to demonstrate that these practices, or to determine if these practices are having the effect that we are hoping they will have, and opening research and making research more rigorous, and then communities can adopt these as part of their normal workflows. And then we also have a policy team who works with publishers and funders, other infrastructure and other institutions to make these practices rewarding, and in some cases even required, which is we move through our diffusion of innovations. There's always some communities that will kind of get to that point before they start adopting practices, but mostly we're concentrating on making things possible and having communities adopt them, not because they're required, but because they're valuable for their research. So take the next slide, please. Thank you. So we're going to talk about the infrastructure component today and how it overlaps with a couple of those other pieces. So the OSF, the Open Science Framework, is one of the primary infrastructure tool that we develop here at the center. And the OSF is a cloud-based open source collaborative management service and scholarly repository that ensures researchers will never lose their own work. So we referred to a couple of presentations ago, generalist repositories. OSF falls into that category as well. Research deposit their data, materials, protocols, a lot of these research materials and types inputs that we talked about earlier into flexible project spaces that support the whole research lifecycle rather than focusing on one particular element of their research. And then they control who has access to that work and when, and decide whether to make all of that public, or maybe it all needs to be private or merely for their teams as that work is developing. And then we, as I mentioned before, do a lot of community outreach and development, some that is specifically with the OSF, and others with research practices and policies, as we mentioned before. And standards and workflows are developed in collaboration with global research communities. They're not things that we just are guessing or determining for communities and put it out there, but rather as a constant dialogue with those communities. Next slide, please. And so this is how we tend to think about the conversations that we have as the infrastructure is developed and iterated on, is we have these three major groups that are a big part of our community development. Members and supporters, we have institutions that are part of our services that support the work that we do and help develop parts of the OSF itself. Integrators, interoperability. So lots of tools that integrate with the OSF, we'll talk about in a moment. And then the users that are contributing data, which is being consumed and used and iterated on and forked by others in the research community at a pretty high rate. We had 350,000 users that are contributing data, but then some of that data is being downloaded over 23 million times just in 2020. So it's being picked up by research communities as something that's valuable for them to build upon with their research. So if you just click twice for me, this sort of confluence of these groups is really how we determine the direction of the OSF, rather than, as I mentioned before, it's not a tool that we put out there, build it and they will come, but rather it's a constant collaboration with all of these groups. Go to the next slide. Just a couple of more pieces referring to several things we've already talked about today. Interoperability with additional tools that accommodate parts of the research workflow so that researchers aren't duplicating effort just so that they can have their collaborative spaces complete on the OSF, or integrate the tools that they already use. Leverage the PID graph to connect researchers to their materials and their materials to related publications, so their final publications can always be connected back to their data and other planning materials and code and software. Specialized interfaces that streamline connections through that life cycle. And then we maintain a free and open API as well that extends OSF features to other tools in the research community, like some we've referred to today. You can go to the next slide. So this is that OSF ecosystem that we referred to. That's really the vision of the OSF, is to have features available at each of the stages of the research lifecycle, so that you can stay in one ecosystem and do a lot of the work that your research lifecycle requires, from discovering new sources, planning and registering your work as you're still conceiving it, conducting and collaborating with your peers, and then reporting and sharing that data. And we have these interfaces in the OSF ecosystem that support each of these steps. And the next slide. And then really the key for us is that we don't want to reproduce features that other tools actually do really well already, but rather we'll integrate those tools in those areas of the research lifecycle that support researchers and research communities. And GitHub is actually the most popular integration that we have because it provides so much flexibility for sharing software and code among their peers, and then as a sort of final research output that they connect with their papers and data sets. And the next slide. So we're still working on the OSF. This is not a complete completed product that we just are handing off and just hoping communities can adopt it, but rather continuing those conversations that we mentioned earlier. So we have a couple of initiatives that are on the horizon and working toward that vision that we mentioned earlier. So we're enabling more connections between registering your research plan. So documenting the work that you're planning to do for your experiments or your project before you go and do that work and publish your paper. And then you can connect it to your paper, to your code, to your methods, and to your other results to bring transparency through that entire research process. And publishers we're not, the OSF doesn't stand alone in prioritizing this, but rather publishers and funders are a big part of this conversation, encouraging in some cases requiring this as part of your research grant proposals or your publication submissions. We're going to implement the credit schema so that all project contributors are acknowledged for their roles in a machine and human readable way. That's a priority for us to acknowledge that there are many ways for researchers or their teams to contribute to research projects, including providing software, wrangling code that is not always acknowledged in the ideal responsible way. So we're going to implement credit to acknowledge those contributors, further leveraging that PID graph to include organization, funder, and equipment identifiers to reliably connect those people, places, and things throughout the life cycle, and really even extending beyond the sort of traditional research inputs and outputs to include things like equipment and facilities utilized. And then we're going to extend that interoperability component in particular is a priority for us as well. So mentioned some of those institutional partners earlier. They support developing and improving those add-ons or the integrations that are important to their communities. So OneDrive is one that will roll out in the next week or so with some really exciting new features. The other institutional partners are developing their own add-ons.
Eric, if you could speed up. If you could speed up.
This is the last section here, sorry. And so other institutions are developing those integrations themselves so we can merge them into the OSF as an open source tool. And we have more community-driven metadata standards and regional alignment that we're working on now. And last step there is just our contact info. If you go to the next slide. So happy to chat with anybody who has interest in integrations with the OSF in particular, or just generally across research infrastructure. Would love to chat with you. Thank you.
Thank you very much, Eric. So this is a very insightful presentation that really tells us that we are doing similar things in both US and Europe. So really should work together more closely. So thank you again. So we will come to the final talk, which is slightly different. This is a lightning talk, which is slightly shorter, so it should only take 5 minutes. So we welcome William Karageorgos. I'm sorry if I pronounce your name wrongly, from Institute of Accelerating Systems and Application from EGI-ACE, who would share with us EGI-AppDB. So the floor is yours, William.
Hi, thank you. Next couple of slides, please. So we're gonna go through a quick overview of some aspects of the EGI application database on research software. The EGI application database is a central service which, among other functions, provides information about software in the form of native applications, virtual appliances, and containers. During its 10 plus years of operation, AppDB has evolved and matured from a software registry started out to encompass today multiple components beyond that, including a sharing and distribution platform for virtual appliances, a VM deployment and management dashboard, an aggregated information system, and the software repository management interface, which all work to support the multidisciplinary EGI infra that is behind it. Next slide, please. As a software catalog, apart from basic metadata, the AppDB describes entries by using a classification system of type, categories, and disciplines, by providing information about supported sites, communities in the form of virtual organizations, supported middlewares, and other information. It also provides version information on software. It cross references between entries through relations and credits authors and publications that have been derived from software. The catalog is accessible over a public graphical user interface, a RESTful API that supports XML annotation, and through an OAI PMAs interface. Next, please. As for publishing metadata, the OAI PMAs interface uses the data site format that follows OpenEUR's guidelines on software repos. All records are persistently identified using HAL PIDs, and filtering is supported through hierarchical sets. There's one for each type of software at the top level, and there are multiple next level sets for each applicable category. Next, please. When it comes to archiving software, AppDB provides a management interface for the community repo with the ability to store multiple source and binary versions of software that is registered in the catalog. The main feature it offers are version of the software based on releases and series. It provides YAM, RPM, and AppDB repos. It also supports source tarbos, multiple operating system flavors, and a simplified web-based process for uploading and managing all the artifacts. Versioning for virtual appliances is also supported, although the virtual machine images are not stored in AppDB itself. Nonetheless, archive metadata for images include a URL where the image, the version of its image may be found, its variation information systems, host requirements such as CPU and RAM utilization, network connectivity requirements, operating system, and much more. Next, please. Before closing, this is a very quick overview. There are some other components that might be of interest that pertain to control the quality of software that is deployed. One of those is the virtual organization-wide image list interface for managing the list of approved and supported software its community wants to endorse, down to the specific versions of virtual machine images. Cloud site managers can subscribe to these images through the provided mechanism in order to provision the software on their infra. There's also an API accessible information system which aggregates and correlates information from multiple sources of the ecosystem about the availability of images on its cloud site and the site status and so on and so forth. And finally, the latest addition is the security dashboard, which is a graphical user interface allowing designated security expert to track the use and the distribution of images across the federation sites and flag potentially vulnerable images in order for site managers to review and then take appropriate actions. That's it from me. Thank you.
Thank you, William. So this is our final talk, and I should make a small comment. So I think the EGI AppDB is definitely interesting, and it will be something we will definitely take a look at in the task force. So I will open the floor now to questions. So you can ask any questions to any of the speakers. So just raise your hand if you have a question. If not, then I will ask. I will ask my question. So the first one, I will address it to our first speaker, which is Pablo. So I really see a lot of synergies between your work and our task force, because DevOps is really considered as an important component to enable our development and sustainability and quality of software. So, I mean, we really like your ideas about open batches. Do you think it is something that you could share with us? Is the standard like widely adopted, or is it really just within your project?
No, I mean, what we are doing in EOSC-Synergy project is this proof of concept in order to use this specification, the open batches specification, in order to recognize the quality achievements of the research software. And then these badges, as I said, can be verified and also shared. So you can share it in whatever platform. And this could be a very nice, from my point of view, way of, let's say, recognizing the quality and probably building reputation on the research software that is distributed through the EOSC.
So I think you have moved already one step ahead of this task force. So we definitely will want to get your input on measuring on some quality definitions and methodology to measure them. Of course, ultimately, we do want some standardization, I believe, too, in order to say what is quality, what is reward. So probably this is something we can collaborate together. I don't. Okay. I mean, I have other coordinators are here, so I don't know if they have anything to add.
I have a question. Sorry, I don't see the button to raise my hand, but
no problem.
Maybe if I may, can I ask if is there any? Oh, okay. Is there any study that assesses like if there is any correspondence between assigning badges versus, I don't know, more reuse by the community or something like that, or is it too early?
Probably it's too early, because we need to see where this goes. One fact that I think that, I mean, for me it's a fact, is that whenever you have more information about the quality of the services and the software, it's good for the user of this service, and probably it affects positively to the adoption, and of course, I mean, we are talking here about also usability, reusability, meeting open science values. So quality in this wide and broad concept that it is can benefit in all these characteristics of software. I'm not aware of any study of that, but I'm convinced that there is some relationship between both.
Thanks, Pablo. So then I'll move on to the second speaker. I think that's Daniel. I actually also have a question for you. So, I mean, in my community, when it comes to reusability and sharing research software, my biggest problem is license, because it's just the open source or it's from vendors and so on. What is the biggest challenge you face?
Sorry, what is the biggest challenge?
Yeah, when you're facing when you're in your project.
In my project. So that there are not open sciences, it's usually, it's okay. I mean, I think that more than open sciences, sometimes there are many other excuses that people use for. So there are two things, right? In terms of reusability, one thing is that, well, sometimes the excuses that people do, because sometimes they are not even aware, right? So they don't put a license and therefore the license is not open. Or they claim that their code is like not in a good shape to be shared by others and therefore they don't share it. So there are many excuses. But for me, at least as a person who tries to reuse software, the challenge is that, as I said, that it's not machine readable, most of the descriptions that I see, and therefore we cannot enforce intelligent systems that start helping, harvesting, and pushing forward, because what I would like to do is push forward best practices. But I wouldn't like having authors to read over standards and try to do it by themselves. We can actually capture some of these things automatically and help pushing this. I think the challenge, to answer your question, is mostly social. It's not that of a technical problem, because, well, doing things right and doing things in a reusable manner takes time. And unless people see that time investment as a worthy investment, it's not going to happen.
Thanks, Daniel, for the very insightful remark, sharing of your experience. We have only 30 seconds left. I actually do have questions for the other speakers, but I'm afraid we might not have. So I'll ask if anyone wants to share any last comments. Just turn on your mic, because I think you might not find the reaction button.
I mean, I do have a question.
Then I think we have 15 seconds left.
I don't want to be the only one.
Answer is yes. So.
So sorry about that. We're running out of time. So we'll see you back in the main session. Thank you very much for joining this session.